I, Tanya Dubey, B student from Department of Electronics and Telecommunications, would like to welcome you all to this VREACH session on communication systems in power utilities. VREACH is a VESIT alumni engagement initiative organized by Internal Quality Assurance Cell IQAC. VREACH aims at reaching out to alumni and enables sharing of their vast knowledge and experience with students for widening their horizons. It also allows alumni to play an active role as a stakeholder and contribute actively in building VESIT's legacy. Moving ahead with the session, I would like to invite our esteemed guest, Mr. Sukalp Kamdi. Mr. Sukalp Kamdi is an alumni from the 2017 batch, Department of Electronics and Telecommunications. He has had an excellent academic record with an aggregate CGPA of 9.56 and bagged a placement in L&T Electrical and Automation as a senior engineer. While in L&T, he worked in commissioning of building automation and control systems for underground metro stations at Doha for the Qatar Rail project. After gaining a 2 years experience in automation project engineering, Mr. Sukalp moved to Tata Power as the lead engineer. He sets an example for students to not blindly get into the race of bagging placements in software companies, but rather focus on their core and ace the placements. I, on behalf of Department of Electronics and Telecommunications, would like to welcome Mr. Sukalp Kamdi to this session. I would now request Mr. Kamdi to begin with his presentation. Over to you, Mr. Kamdi.
Good morning, everybody. Thank you, Tanya, for the lovely introduction. Thank you, VESIT team, for giving me an opportunity to talk on this platform. And today, I am in Tata Power Company Limited as a communication engineer. Before I dive into my presentation on what is communication in a power utility, I would first give a background of what Tata Power is in Mumbai. Tata Power is a power generation, transmission and distribution utility which is responsible for supply of electricity to all consumers at 220 kV, 110 kV, 11 kV, 22 kV as well as up to 415 volt consumers in Mumbai license area. Tata Power is having its generating facilities at Trombay, thermal generation with its hydro electric generation at Khopoli, at Karjat, and at Bhira in Raigad. All these generation plants are responsible for supplying electricity only to Mumbai license area. And in Mumbai, we are having more than around 30 to 35 plus substations. We can call it as the receiving stations, 220 or 110 kV substations, more than 450 distribution substations at 11 kV and 22 kV levels, and more than around 950 consumer substations, which are responsible for lighting up homes of Mumbaikars. We are having a state-of-the-art automation system which is managed from Trombay, wherein each and every substation in Mumbai is remotely operated because every substation is unmanned and all controls of every substation is totally managed from Trombay through operation engineers. This remote operations is only possible because of fiber optic communication, which is spread across whole Mumbai, right from Kolaba in south up to Mira Road in North Bombay, and fiber going up to the hydro generation stations at Khopoli, Karjat, and Bhira. So it is accounting of around 1,000 plus kilometers of fiber, which is being owned, maintained by the communication team in Tata Power. Not only maintaining the fiber infra, we are also responsible for multiple applications which are responsible for running this utility, which I would take you through in the presentation here. The basis of this presentation is to give what, as a communication engineer, is doing in a power utility, or you can say what are the systems, communication systems in a power utility. I would be giving example of Tata Power, but you can extend this, you can say to the state transmission utility, you can say which is the Maharashtra state or MP state, UP state. And the same similar such system is also expandable right up to the national level, which is run by the PGCIL or the regional load dispatch centers. The system is the same, only the quantum of the system is big. The basis, the concept remains the same, only the system quantum is big. So whatever example I would be giving here, you may correlate the similar scenario in bigger utilities. Not only in India, I would say it's across the world, which is being done, and uh, constant developments are being done. How to fine tune it and how to more and more get in digitization, get in more of intelligence in this automation, which we strive to do it in any power utility. Apart from this, we are also into renewable generation, renewable energy, EV charging, and which is into promoting more of use of renewable energy. As you all know, the conventional energy sources are going low, and it's a need of the hour to reduce our carbon footprint. So as a power engineer, I would always be, promoting this to have a greener life, greener earth in future, as we are moving towards zero carbon emissions by 2040. So without wasting any time, I would just quickly dive into my presentation. Here we go. I would start with my presentation here. As I said, I would be briefing you about what are the communication systems in power utilities with some examples of Tata Power. So this would be the flow of my presentation. I would first give you the overview of what is the communication system, what is the fiber system which we have implemented in Tata Power, the SDH multiplexing system, the layer 3 networking infra. We are obviously moving towards MPLS as SDH technology is, although the technology is developed, slowly, every technology has an end of life, which is approaching soon. Within, I suppose, in 10 to 12 years, SDH might come into an end, and everything would be purely MPLS. As we are in a transition phase. Our VoIP network, we are also having IP radios, which I would just touch upon, and cyber security initiatives for preventing any cyber attack. Now, overview of the systems in Tata Power. If I say, we are having fiber media, which is the OPGW and underground. What is OPGW? OPGW is basically optical guard wire. Now, what is guard wire? Again, guard wire is an electrical term. Now, whenever, if you have ever seen a transmission tower carrying electricity, you might have seen it as you all travel along the Vashi Creek, or you might travel along the Eastern Express Highway. You might have seen tall transmission towers, high voltage towers. These towers belongs to Tata Power. The conductor, which is at the peak of the tower, which is at the tip of the tower, that conductor serves two purposes. The major purpose is to give grounding. Any electrical system, whether it is at low voltage or whether it is at higher voltage, you require grounding. That conductor serves a medium for giving grounding. But more than that grounding, inside that conductor, we are having optical fiber running, 48 core, 96 core fiber running. These fiber optic cable, OPGWs are transversing across all receiving stations in Mumbai, which are responsible for giving communication connectivity across Mumbai LA, Mumbai license area, right up to our hydro generating stations. This fiber optic network of OPGW and underground fibers is forming the backbone of whatever applications which I'm putting up here. So the first application which is required as a power utility is teleprotection. Now, the term teleprotection is a very generic term. To explain it, whenever you're having high voltage systems in a power in a system like in a power utility, you need, the major threat to any high voltage system is high current, high voltage. If there is high current, high voltage, the fault level is high. Kiloamperes of current is generated whenever there is a fault, and if this fault is not eliminated, it may cause damage to the equipment, it may cause fire, it may cause loss of life. So to protect these systems, you require some sort of a protecting mechanism wherein if there is any fault in the system, you are able to isolate your live system, your other live system, before the fault current is actually coming and damaging your system. These protecting systems are required for all electrical equipments like your transformer, your electric lines, your reactors, your capacitor banks, whatever. Now, whenever you're having EHV lines, like say running between two substations, like say station A and station B, you need to protect that electrical line. Protection in the sense from faults. Fault can be a major fault or it can be a transient fault. Now, if I talk about a transient fault, it may be like you might have always heard about during the Makar Sankranti festival. People, you might have always heard about the kite getting stuck in the electrical high tension towers and people are getting electrocuted. Now this electrocution, once the fault current has already flown through the body of the person, it will never persist. The fault will get rectified and the line will always go through. So this is a transient fault. This will last only for say a few seconds and the system is restored. Now, this matter of 1 second or the milliseconds, the protection system has to be accurate enough. Whatever electrical faults happen, the latency is in milliseconds and microseconds. So this fast means of communication, fast means of protection is possible only through fiber optic, which is wherein light is the media through which light and you can say higher wavelengths of light are used to transmit signals. The overall latency in the network in Tata Power is maintained up to 7 milliseconds. 7 milliseconds maximum latency you have to maintain. Otherwise, if there is a latency or if there is a delay in your signal reaching the other station, and if there is a fault, the entire purpose of a communication system goes for a flop. So teleprotection or protection of the high voltage equipment is the major requirement of major application of the communication system here. Next, SCADA. SCADA is supervisory control and data acquisition system. To simplify this word, when I talk about automation, when I'm talking about remotely handling, remotely operating a substation from say centralized location. The substation, say suppose my substation is located at Bhandup, and if I want to operate, if I want to open a breaker in Bhandup, the command is given from Trombay. Now how this command is transmitted through our network, through the fiber optic background media to Bhandup, and from there the breaker is being opened. Now this is possible only through some sort of an automation, some network which is connected to the servers at Trombay. Now this is possible only through a fiber optic media. Now these two are very critical applications wherein even if these two are not working, even if I say my surveillance camera is not working, it is okay. But at the time of contingency, these have to be available because these are mission critical. Tomorrow, if my consumer, what is the aim? I have to ensure 100% power to my consumer. If my consumer is not getting power, it is a loss to the company. It is a loss of generation. It's a loss of revenue to me. So these two applications are actually termed in mission critical applications, which is required. Now, IT, corporate IT, the local intranet which is used across Tata Power is also based dependent on our fiber optic media. The surveillance system of Tata Power, it is through our media. Now you may wonder, if we are using so much of fiber, we are also going into leasing of fibers. Today you might have having that Jio. Today Jio has set up its entire network in India. Today Jio fiber has reached every home. Now what is the background? What is the base of Jio fiber? Today Jio is using leased fiber of power utilities through their OPSW, Power Grid, MSCTCL. All major state transmission utilities are leasing out their fibers to Jio. This is the reason why Jio is able to penetrate into your network, because OPGW is one type of a media which is extremely reliable. This, physically this conductor is on the top of the tower. obviously no human intervention is going to go and damage this OPHW, or you can say go and cut it. Whereas on underground fiber, it is simply dug into your road through your footpath. And you all know in Mumbai what is the condition of the roads and what is it all about. Multiple cuts, multiple damages to the fiber. The reliability, level of reliability you get in OPHW, you can say till 10 to 15 years, this fiber is unmatched. The reliability of this fiber is unmatched. 10 to 15 years, hardly any degradation in the fiber. So this is the beauty of OPHW. So this is such a lucrative business for all your telecom operators, like you can say Jio, Vodafone, your Airtel. They approach power utilities so that we give our fiber to on lease, which is again used as a medium to connect to your homes. So this is, and obviously we are also having our internal VoIP network, the voice over the internet, you can say the intercom system, which is again based, having the background of our fiber. So this entire setup in Tata Power Mumbai is maintained, managed by communication team. Today, I'm proud to say we are a group of only 4 engineers or 5 engineers working, and we are managing this entire network. So uh, this is how the power fiber system is being maintained here. So what is my role? My role as a communication engineer, my major role is whatever power system control center we are having in Mumbai, we have to give service. Services to testing team, the protection, EHU protection team. We are giving support to them for their electrical protection. The OPHW and fiber management, maintenance, fiber leasing, the distribution, like we have for transmission, 220 kV and 110 kV voltage levels, we are having their automation. We are also having automation for 22 kV, 11 kV, 415 volt level substations also. These are also almost, I can say in Mumbai, 85 to 90% they are automated. Why 85 to 90? Obviously in Mumbai, wherever fiber is possible, we have automated. In places where feasibility of giving fiber is not, obviously they are manually operated. But yes, the criticality of these substations is not as high as a high voltage substation. So we have made sure automation is being maintained right up to my uh, low voltage level also. The enterprise intranet we are using, the telephony services, and obviously whenever we are into maintaining and our fiber optic systems and protection system, we also into design. We give design support, we give evaluation to designing any such system which is coming up. We give support for commissioning of all these telecom systems across Tata Power also. We also give some support to other subsidiary distribution companies of Tata Power in Odisha, in Delhi. We give support to their technical support to them also. So this was all about my role in Tata Power. Now, as I said, we have about 1,000+ kilometers of optical fiber, spread across Mumbai, of which 750 kilometer of OPGW and around 250 kilometer of underground cable. Now, if you imagine Mumbai, underground cable is mainly the network of underground cable is more dense in South Bombay region. The reason being obviously the land in South Bombay is very, the area is very small. You cannot have a transmission tower standing all the way in between Gateway of India. That will obviously, spoil the entire thing of the beauty of the entire thing. So we have converted all our network in South Bombay into underground. We have deployed high-speed fiber optic terminal equipments like ABB Fox 20. I'll be going into detail about all these brands, these multiplexing systems in my uh, upcoming slides. We are having OSPF based communication network across all my transmission 35 to 40 nodes which we are having here. Entire network is a IP switching network purely based on OSPF, no static routing involved, no, it's totally hassle free. Now, as what is OSPF? OSPF, I would again go into deep in my upcoming slides. We are having giving support to SCADA, the metering. Now, you might have always heard about smart metering, and what is smart metering? Today, whenever you are consuming power through any substation, the metering, what is your consumption, power consumption daily, that is being recorded through this network. Now, whatever consumption you're having over a period of time, this entire database is used for forecasting the consumption in the future. Like today, if I'm having consuming X units of electricity, then tomorrow X plus one, then X minus one. So entire this database over the years is uh, being maintained at metering servers, and this database is used for forecasting power consumption, predicting the load. Now load prediction is also like today, if at this moment of time, means like if it is around say 11 a.m. today, at this moment of time, if I am predicting a load of say 100 megawatt, tomorrow at this moment of time itself, I may be in a position to having 100 megawatt. So that forecasting is done only because of this database, this metering database. Okay. The relay system which we are having for protection, the power quality measurement. Now, what is the power quality? Power me how smooth is your sine wave? That is also required. Like whenever you're generating power, it's obviously in a sinusoidal form. Now, how smooth your sinusoid is, that is the power quality meter. Power, we, that is how the power quality is maintained. Then we are having VoIP based EPBX. Now, what is EPBX? It's simply a telephone exchange, enterprise based telephone exchange. Now, what is the network component? Basic physical media. We are having OPGW, which is the fiber optic cable. It's a 2 core, 6 core, 24 core, 48 core, right up to 96 core. Today, the first ever fiber optic cable, fiber optic OPGW in India, I should say, was laid by Tata Power. We are the pioneers of laying it. In the year 1984, we were the first utility or mm, the company to start fiber optic network in India. It was the first fiber, two core fiber. It's having only two cores of fiber in that, one for transmitting, one for receiving. That two core of fiber was first laid by Tata Power right from Trombay in Chembur up to Masjid Manzar. So this fiber is still live, still network is working on this, and this is the reliability of OPGW. Today, obviously there are faults in between, we do rectify it, and today we are reaching around 30-35 years, it is still working. Then as and where the requirements increased, we went for 6 core, 12 core, 24 core, 48 core, 96 core. Beyond 96, yes, there are OPGWs, but we haven't gone because whenever you are increasing the size of the OPGW, your conductor thickness goes on increasing, and yes, it has effect on the overall loading of the tower, overall properties of the conductor, which we have to maintain from electrical perspective. We haven't yet ventured into going for higher capacity fiber, but yes, it is possible. Underground fiber 24, 48, 96 core. Underground fiber, yes, 144 core, 248 core fibers are used by telecom operators like Jio, your Vodafone. They are having high capacity underground fibers. But in power utility, we are not into that dense network, high amount of application. Our application is limited maximum up to 96 core. But yes, there is scope for expanding. We are having SDH, MUXIS. SDH stands for Synchronous Digital Hierarchy, which that concept you will be learning in your third year. The basic concept you'll be learning in your third year. I may not, going into the detail of SDH because this is not the forum. Because if I start going into SDH, it will become very much monotonous. So I will not go into that. SDH multiplexing systems. on STM16, STM4 level for teleprotection. Stack IP switches, layer 3 switches. Layer 3 is the third layer of the OSI, network layer. Network layer obviously stands for the routing layer. And if a switch is in the network layer, yes, this layer 3 switch acts like a router. This is a switch having routing capabilities, but not exactly like a router. It's having routing facilities. So for our remote operations, whatever operation if we are doing from Trombay for all our remote nodes, it's possible only because of routing. The metering, automated meter reading, power quality, and my telephone exchanges. So this is one basic diagram. You can see the fiber optic network in Mumbai. From Trombay, you can see my fiber is going right up to Khopoli here, which is in Raigad, right going up to Ambernath from Bhivpuri, which is Karjat. There it is going from Kalyan, Bhandup. It's like an entire mesh of multiple nodes in Tata Power, which we are well connected through fiber, through existing OPGW network, underground fiber, some ADSS. ADSS fiber now we have almost decommissioned and upgraded into OPGW. Yes, there are some leased bandwidths which we are taking wherein some fibers are not available, wherein we need critical connectivity. We do take lease from telephone operators also. And there are some proposed OPGW which we are planning to commission in future. Yes, as and where we get the budget and all, we will be definitely upgrading the network. Now this is the OSPF switching network which we are having. Now you can see the topology here. It is completely a mesh topology. Every neighbor here is connected to some other. So we are maintaining that level of redundancy. Tomorrow, if any fiber is going down, my substation, Saki substation, Bhandup substation is available to Trombay from any other network. So this is how critical the network is, and this is the criticality of communication here in the automation of power utility. Now this is also a type of a network diagram which we are using for my SDH system, SDH multiplexing system in which is like Trombay. You can say Dharavi is one location, Mankhurd is one location, BKC is a location. So this is, you can say, some sort of a mesh. I mean, this is not the complete diagram. This is a very skeleton which we have made. The if I draw the complete diagram, it's like a totally complex diagram which is there. Now talking about the distribution substation and the consumer substation. Now distribution substations are located at very small locations here. Now number has gone up. Like in the last month, we have crossed 50 distribution substations which are connected on own fiber. Now wherever the fiber is not possible, okay, see, fiber is something, if we want to lay fiber, it obviously involves some cost, some permission from the local municipality, the trenching, all such social things are there. So wherever it is possible, we are obviously going to physically laying the fiber, but wherever it is not possible, we are taking support, we are taking use of the Vodafone cloud. Now, Vodafone, if you think is only responsible for giving cellular services, no, Vodafone, Airtel, and all these service providers are also responsible for giving you leased bandwidths, point to point bandwidths. They're having their own fiber network, they're having their own clouds. Suppose if I want to have a connectivity from say station A to station B, I can simply request Vodafone to give it. So Vodafone through their own network will give a point to point VPN based connectivity. So these substations are connected on Vodafone cloud. This network is, they also use SIM cards. The entire system is based on SIM cards, and these SIM cards are having a phone number as well as an IP address. Okay, it's simply not a phone number, it's also having it's an IP based SIM. So these SIM cards report to the Vodafone cloud across Mumbai, and through their cloud these IPs are these SIM cards are reachable at our substation. So this is through Vodafone. Now yes, obviously if there is a big crisis of Vodafone in Mumbai, we obviously have a backup of Airtel. We obviously go for change over to Airtel. and other service providers. So this is also a type of network which we are maintaining with the collaborative support of Vodafone, Airtel, and obviously Jio is also slowly penetrating. Now, what is the application here? We are obviously having communication connectivity to substation SCADA, to my control center. Now, what is ICCP? ICCP is the Inter Control Center Protocol. I mean, this is a very much, you can say, what you can say, proprietary to a power utility. Tata Power as a utility is supplying power to BEST, which is your Bombay Electric Supply and Transport. It is the major customer. So we are connected to their system. We are connected to the state grid, which is your Maharashtra State Electricity Board. Now the board is not there. We still call it MSEB. It's the state transmission utility. Okay, so these are the points which we call the tie points. Now, whenever we are getting connected to their networks, okay, it's a foreign network. This is a third party network to Tata Power. So, whenever there is a third party connectivity to other networks, we have to maintain that ICCP connectivity with adequate cyber security. Then the ABT metering. What is ABT? Availability based tariff. I mean, based on the power consumption, the power tariff, the power, what you can say, billing is done through these meters across all receiving stations, across all consumer points. These meters are installed, and these meters are used for billing your power across, the entire utility network. Relay networking for protection. We are also giving support for the automation of the hydro plant, their dam operation, their gates operation. We have also designed a centralized control network for hydros, wherein all the hydro plants can be operated from a single point. There is a provision, but currently they don't. But yes, there is a provision we have done whenever they wish to operate it centrally. And obviously, connectivity of remote consumer substations. What is the SDH multiplexer? As I said, they are used for teleprotection, the carrier protection of 110 kV, 220 kV transmission lines. Now, carrier is basically the term which is used in electrical utility for communication. Carrier, right? Carrier is a medium through which the command of that relay is transmitted from one receiving station, one substation to other substation. So this type of protection is used for the EHV lines. Differential protection. What is the differential protection? Simple. I mean, in a very one word, differential. The word itself gives you what is differential. Differential means one relay at substation A, another relay at substation B. If there is a difference in the current read by the substation, I mean the same line showing different currents at both ends, yes, there is a fault in the line will trip. This tripping is known as differential tripping. So now this protection is giving on direct fiber, wherein the relays between the two differential relays between the two substations are communicating on direct fiber. So this is the fastest means of communication, which is in 5 milliseconds, or you can say 3 milliseconds maximum. For around 120 kilometer of fiber, we have tested the delay is maximum up to 5 milliseconds, which is the fastest achieved till now for us. So which is a very high speed data link for the line differential relay. Yeah, obviously this is the similar connectivity for my enterprise IT also. So wherever my fiber is there, the enterprise intranet is also present, and this is also what we are maintaining. Now this is where we have given our fiber to enterprise network, my surveillance network, and in case if there is no direct fiber, yes, we do take bandwidth provided from Vodafone, from all this. So these are all of my team roles. We do day-to-day O&M of my communication network, project commissioning, as I all said in my previous slide. We do evaluate new technologies. Like obviously, it's not like we are having some system we are maintaining. Every day in day out, we are taking steps like how we can go forward and upgrade my system. Like you can say, communication field is such a field, like every now and then, every 1 month, you can say the technology is changing. Today we are started testing 5G. In couple of years we might go into 6G. we might completely migrate into software defined networks. I mean, it's totally, I mean, in a couple of years, it will be totally a different scenario altogether. Market, obviously, we do a study of the market for all networking products which we can fit into our power utility. We lease our fiber to all, and obviously, we do have a disaster management plan which is required for maintaining the criticality of my network. So if I go into what is a fiber, like I'm speaking about OPGW and speaking about fiber. Now considering my audience here is from second year, third year, you might understand, you must know what a fiber is about. Fiber is simply a thin, long strand of pure glass, which is used. The light is the media, or you can say the electromagnetic wave, which is used for transmitting signals from one point to other. And the principle of operation is total internal reflection. I mean, this you will learn in detail, obviously, in your core courses. But yes, as a background, I will obviously give this. So if you see, the fiber is having a coating, then there is a cladding, and inside that cladding, you're having the actual glass core through which the light is being transmitted. What is the advantage? The fiber is very thin, fiber is less expensive, high density of data which you can transmit from one to other, extremely high capacity. The capacity, it can be like a single core of fiber can have more than say 5 to 6 wavelengths or 5 to 6 applications running parallelly on a single core of fiber. This is how dense a fiber can be, application wise. Very less degradation. I mean, unlike copper as a media, you may know, there is very less attenuation is the correct term which you can say. Very less attenuation in a fiber media. Non-flammable, obviously. There is no fear of getting shock, no fear of any hazard. It's light in weight. Now further, it's having very high bandwidth, gigabits, terabit per seconds of bandwidth you can have. Ideally, infinite bandwidth, but practically I can say gigabits. Immunity to noise, yes, it is immune to all electromagnetic interference, or you can say any electromagnetic radiation. It is immune. Safety, no electrical signals. Obviously, there is no risk of any shocks or So it is safe to operate for critical applications like gas pipelines, or you can say any high voltage electrical system. Highly secure. You cannot tap into a fiber like how you can do for a electrical cable. You can simply attach jumpers and get it in parallel, and that's how thefts are occurring. This is impossible. You can't tap into a fiber. If you tap into a fiber, your fiber is cut, and you are coming to know, was my fiber is cut, somebody is trying to this is impossible to do. Less loss, yes. You are having hardly zero point 0.2 dB per kilometer of attenuation. And if you're having kilometers of fiber more than 200 kilometers, we have to keep some repeaters. Yes, obviously. If you're having very high distance, 300 kilometers, 400 kilometers, you need to have some amount of repeaters. But unlike repeaters in copper media, this is like within Tata Power, since the distance is not more than 200 kilometer, we don't have repeaters. But yes, for power grid, for MSETCL, where you're having high, long distance lines, lines, high voltage lines, 400 kV lines, 765 kV lines, which are traversing from one state to other. They are also having OPGWs, and their systems make use of repeaters, which is required for boosting your optical power. You do require them somewhere. Reliability, obviously more reliable than copper. Size, light, obviously flexible. Unlike brittle glass, fiber is very much flexible. It is not pure glass. You obviously have some additives in glass to make it more flexible. Yeah, obviously there are some disadvantages. Uh, Fiber optic systems, yes, they are very critical. They are very costly. Interfacing systems, the equipment, the terminal equipments are very costly. They run into crores. Today, if I'm having a normal a simple multiplexing system being installed in my substation today at this time, considering all that, semiconductor shortage, copper shortage in the world today, it is going into more than 80 lakhs or 90 lakhs. This is how costly it is. For a short distance communication, say from for a 1 kilometer, it is obviously a costly affair. I mean, considering your criticality, it is yes costly. You require high amount of skill to maintain it. Highly skilled people. You cannot be rough and tough. You have to be very delicate, as the fiber is as thin as your hair. I mean, you cannot be clumsy with handling fiber. It's very very delicate, and adding multiple nodes into physically into fiber, it becomes difficult. Yes, the density of fiber goes on increasing, maintaining becomes a bit difficult. Though, as I said, the optical fiber consists of a coating. Yes, this is the protective coating which you can see. And inside that coating, you are having a cladding, and this cladding is having a refractive index less than that of the core. And this is the main principle. Like, since the light is traveling from a denser refractive index to a lower refractive index, the light is getting totally internally reflected. So the cladding, obviously, you should remember, it's having a lower refractive index than the core. So this is how a simple fiber construction is. This is how, if you see the, wherever you're, suppose you're traveling along a footpath, you might, come to see these orange color cables, hanging by the tree side. Obviously, Tata Power doesn't hang fiber on the trees. We have proper trenched roots. Trenching is done along with my power cable. We install fiber cable so that they are protected from illegal trenching. Wherever my power cable is running, we are having fiber cable, and they are protected using those power cables also. This is the actual armor. This is the steel strands, you can see, steel, or you can say aluminum cladded steel. That's how reinforced it is. This is an insulation jacket. This is another set of strengthening wires are there, which is giving some additional strength. This is the main tube, and inside that tube you are having the optical fiber. So this, you can understand how armored the fiber is. Yes, obviously, if you cut it, and if you purposefully go and bend it vigorously and violently, yes, it does get damaged. Obviously, it is not unbreakable like something. Yes, we have to handle it with care. You have to keep it properly. You cannot bend it as and where you like. Okay, this is how your total internal reflection is. Your incident layer of light coming into the core, and then if the angle is greater than that, it gets total internally reflected. So this is how your light is transmitted from one location to other. This is how your fiber works. Now the wavelength, now how can, obviously whenever you are connecting fiber, there are obviously some losses. Losses are there. Some losses are in the system by default. There are some by default losses which we have to consider when we are designing any system. You can say, the fiber cores are not matching. You are having, different apertures, so there is a loss. Different refractive index of fiber, yes, there is a loss. If you are not coupling the fiber, not splicing the fiber properly, yes, there is a loss. So yes, these losses, if you can say these, like 1, 2, 3, 4, these are all caused by human, when we are, jointing fiber, joining two fibers. So these are there, these losses get introduced. Now, based on the diameter of your core and cladding, you're having two types of fiber. Like, you're having a multi-mode fiber, you're having a single mode fiber. Simple. How to remember? Whenever your core diameter is 9 micrometer, single mode. Greater than 9 micrometer, multi-mode. This is how it is. 9 micrometer is the standard. It's not less than 9, not greater than 9 for single mode. It is only 9 micrometer single mode fiber. 50 micrometer to 62.5 micrometer, it is used for multi-mode. Like, now if you think, since the core is very having thin diameter, the ray of light can have minimum number of reflections inside and it can travel more far. So hence, if I say your single mode fiber is going for long distance communication. For greater than 2 kilometer, you go for single mode. Up to 2 kilometer, multi-mode is you can say feasible enough. You can use multi-mode fiber. So when you are designing a communication system, whenever you're designing a network, say suppose you are designing any network within your department or something, if you are able to connect 2 or 3 rooms together, you need not use a single mode fiber. You can do it with a multi-mode fiber also. So single mode fiber here becomes a costly affair. You can simply use a multi-mode fiber. This is how, within the building, if you want to create a network, you can use multi-mode. Building to building, building to multiple buildings, go for single mode. As simple as that. So the wavelength of light, standard wavelengths which we use for communication worldwide, 1310 nanometer, 1550 nanometer. These are the two basic wavelengths which we use. And at every wavelength, higher the wavelength, lower is the attenuation per kilometer. So this is the property which we maintain across all systems. 0.22 dB per kilometer, and attenuation for multi-mode fiber is a bit different. More attenuation because, as I said, the core is large. Now this is how your fiber accessories look. Like you might have seen this fiber joint box, that black color thing, hanging somewhere around, the walls, or, hanging around the footpath. Simply, this is a fiber joint box. Two fibers are entering here inside, all your fibers are spliced together. This is a termination box. Like suppose you want to, the fiber is, connecting from one station to other. And if you want to interface all your application here, you need to terminate that fiber over some, equipment. This is a termination box. Simply all my cores, 1, 2, 3, 4, you can see are terminated over here. So this is how the fiber is. This is where your fiber is spliced, and this is where you are getting it terminated. It's a termination box. This is your type of fiber patch cords. You simply connect one device to other device. This is a type, fiber patch cord. Now these colors are also standard up. I mean, you can say yellow color stands for single mode, orange color stands for multi mode. This color is kept, constant all over the world. I mean, for a communication engineer. Obviously, for OPGWs, which is a conductor, there is a special joint box, which is the metallic enclosure. This is where the holes, you're connecting all your OPGWs. Now these OPGWs, since it runs from tower to tower, these joint boxes are placed on the top of the tower. Okay, we have to do the jointing the OPGW at the ground, and the joint boxes are then tied on the top of the tower where they are safeguarded. So different type of patch cords, if you see different types of connectors, ST coupler, FC coupler, SC coupler, these are the different types of fiber optic connectors based on your applications, how you interface your application. This is all all about it. Now, yes, obviously there are some test equipments wherein you test the healthiness of your fiber. This is the splicing machine, which is used for joining two fibers. There is a electrode inside, a heating electrode, wherein two glass fibers are coming and they're getting fused into each other. So this is the splicing machine. This is a OTDR. OTDR is an equipment which is used to measure the healthiness, measure the attenuation, measure the cut or the degradation in the fiber. Like the principle of OTDR, I mean, I would say as a communication engineer, wherever you go, this concept becomes very much what you can say essential for a communication engineer to understand what is an OTDR all about. You are having optical power meter. You understand how much amount of optical power in electromagnetic power you are receiving at one end. You can test the healthiness of that. You're having a laser source. Visual fault locator. You can say laser, red color. Visually you can see. These are all our specialized tools which we use. Like when I'm speaking about OTDR, yes, I will simply explain it in 4 sentences. Now, what does an OTDR do? Simple. There is a laser source. The laser is launched into the fiber under test. Like if you have one fiber, you just want to test it. You will simply launch the laser here. So wherever there is a reflection or there is a cut, the laser light will come back and get reflected over here. So based on the time taken for the pulse to come back, and you know the speed of light, you know the time taken, it's calculated, you come to know a graph is plotted showing the loss in the the optical power over distance. So here you can come to know, like suppose if I'm transmitting say x amount of power and I'm getting around x minus 10, so you will know that there is a 10 dB loss. So what is the loss due to? Here you will see there is a connector loss. Here there is some splicing loss. Here you will see, the fiber is coming bent. You can understand this is a bend. You will see the fiber is bent at say 1 kilometer from the earth. So this is how you evaluate, the healthiness of the fiber. So you are able to locate, measure, the loss using OTDR and troubleshooting, the fiber if it is going bad, if it's going degraded. So this is the different type of wavelengths which we use. These are the standard ITUT bands: O band, E band, S band, C, L, and U. And the wavelength goes on increasing from 1260 to 1675 nanometer. Uh, uh, this is more towards your ultraviolet side. This is the ultraviolet side. This is more into infrared. I mean, lower the wavelength, it is into towards infrared side, and higher the wavelength, it's towards your ultraviolet side. So this is how you go for your major applications lie in between this O band and S band. These are all applications still there, but very rarely they are used. I mean, specialized applications which are used by telecom operators like your Vodafone and all. If they are having multiple applications, they do use. But in power utilities, you need not go into those wavelengths. In power utilities, you only use three wavelengths: 850 nanometer for multi-mode, 1310 and 1550. Simple. Only two wavelengths are more than sufficient to suffice your power utility application. Why these three? They are tested. They are having the lowest attenuation. Longer the wavelength, yes, less will be the attenuation. 1550 is typically popular because of low loss. So very high distance if there, we obviously go for 1550. And amount of bending and the quality of glass material what is used for the fiber, yes, obviously affects your fiber utility, your fiber loss, your fiber quality. And yes, bending to some extent is allowed, but if you go and bending it in a right angle, yes, the fiber will break definitely. So the fiber is completely damaged. You cannot repair it. You have to cut it and you have to again rejoin the fiber. Now, what is wavelength division multiplexing? Like, suppose today, if I'm saying I'm having multiple locations, and if suppose I'm having very less amount of fiber between two substations, but I'm having multiple applications which I want to run, like my SCADA, my metering, my multiple applications are going. So I can assign one wavelength to one application, and multiple wavelengths, I can combine in a device called a wavelength division multiplexer. It's simply a passive device which combines all wavelengths of light together on a single core of fiber, and at the other end it is split again. So this is how a wavelength division multiplexing is done. Like at one end, different applications are connected at different wavelengths. You're simply, this is getting combined, through, different angular splicing of glasses inside the wavelengths gets combined. But yes, if the wavelength is getting combined, they'll never mix up. Wavelengths of light never mix up with each other. This is the beauty of light. I mean, this how it is. So at the other end, you have to simply split these wavelengths back. So if I'm having a link running on say violet color wavelength, I can same get this link out at other this violet color out somewhere. So this is how WDM, you can say, a system we used to transmit several signals together and demultiplex it back. This is where this system is not actually deployed in power utilities because we don't have that much density of applications considering the criticality of our system. This is actually used in your telecom, telcos, telecom providers. You're like Vodafone, they're having high density applications, multiple applications running across multiple links, multiple capacity of links running across all this wavelengths. They do use WDM. They use dense WDMs, coarse WDMs. They do use. These are some simple devices which we use. It's an FOT, you can say fiber over TCP/IP. You can say it's simply a converter which converts your Ethernet into, you can say, a fiber. Simply a media converter. There is no logic. There is no anything. Simply it converts my Ethernet signal into fiber. Simply, if I want to connect my LAN cable LAN from here to a distance greater than 80 meter, I have to see. You all know Ethernet cannot operate beyond 80 meter conceptually. So you have to, obviously, if you want to pull an Ethernet connection up to say greater than 80 meter, you have to go for these media converters. So these are simple media converters. This is the SFP. You can say the fiber interfacing module, small form factor pluggable module. You can say. Which is used for giving that fiber interface. This is a network switch which is having fiber ports, which are having Ethernet ports. You can see that. Now coming for multiplexers, what is multiplexing? I mean, when I'm speaking so many times, I spoke about multiplexing. What is multiplexing? You know that answer would come, yes, combining multiple inputs to a single output. Combining a single output, giving out multiple, a single input giving into multiple outputs. Diagram, say, you can say it's the same thing. You are combining multiple applications, line protection, C37.94 IEEE protocol, Ethernet application like of SCADA, Ethernet application of say corporate IT, Ethernet application of CCTV, Ethernet serial also comes, RS232, RS485. Suppose I'm having only one pair of fiber. I want to say optimize my fiber. See, fiber optimization is also a type of an engineering. You can't say I'm having multiple fiber. I'll, splurge over that. No, that's bad engineering. You have to optimize it. Wherever optimization is required, you have to optimize it. So suppose I'm having a single pair of fiber and I want to run multiple applications. Simply use a multiplexer. You may also use a WDM. Definitely you can use a WDM. But yes, WDM, if you're using a WDM, your application interface has to have that color wavelength, different color wavelength. But these applications like teleprotection, this protocol, Ethernet, they don't have wavelengths. You need to have that application level inside a device. This is a device called a multiplexer, wherein multiple applications of C3794 protocol, they are converted through their logic into a signal which is coming out of this fiber. All these applications are aggregated through a fiber, and from this fiber it is connected to the other end, and at this other end through this fiber these applications are again coming out of the different application parts. Simply like teleprotection, but teleprotection of line, this is this require a bandwidth of say maximum 64 kbps, simple a voice bandwidth. Very a small amount of data is required, because bits of signal, like if I want to give an open close command, ones and zeros, I mean this doesn't require a bandwidth, a huge bandwidth, ones and zeros. So teleprotection, ones and zeros. Binary inputs, you can have one card, you can have an application of binary inputs. Okay, binary inputs is coming, it is getting converted into some electrical, that logic is being built up, and through this aggregator fiber port it is coming out to the other node, it is coming out. Simple, this command from here, ones and zeros are transmitted here. This is how it is. C37.94 is a proprietary communication protocol, typically for power utilities. I'll not go into this. It's simply theory. I mean, the application is only for differential protection of relays. I mean, purely for relay differential protection, we use C37.94. Now, you might have, if you recollect, I had said, like in my differential protection, whenever you are having abundant fiber, you can simply connect two relays through direct fiber. But if I'm not having direct fiber, I'll use C37.94 protocol for a relay. I'll connect it to my multiplexer at one end and get it out on the other end through the multiplexer. Simple. The relay will communicate. Simply, it's a communication media. Ethernet application like SCADA, IT, CCTV, simply you are able to multiplex it out, through this. So this is the multiplexer. SDH is one the the protocol which is used for the multiplexing device, which is the synchronous digital hierarchy. Multiplexers also use PDH, which is the lower version of SDH, which is the Plesiodonos digital hierarchy. SDH got developed from PDH, and Sonet is one counterpart of SDH, which was never that developed. It was only used by the US Army. It never got you can say marketed through our network. PDH and SDH was you can say the best ever technology at that time, which was developed for uh, uh, for all type of applications, and especially for power utilities. SDH is the fastest ever, proven fastest, guaranteed response, very fast network balancing, very fast changeover times is obtained through SDH. But yes, SDH is also reaching end of life. There are technologies which are giving tough for SDH, which are being developed, which would in future I can say near future, over the next, I'll say 4 to 5 years, SDH will also slowly be start getting replaced with technology like MPLS, multiple multiple packet label switching protocol. So this is one which combines multiple application of data voice over single fiber for two locations. Very fast switching, very high bandwidth SDH. The SDH multiplexer, which I was talking about, how the line protection is working. Here, the protection relay is connected to my fiber optic, terminal equipment, which is my multiplexer, through some, command cables. Whenever this relay is getting picked up, that binary input is getting high. It is getting through my terminal equipment, and through this here fiber optic network, it is getting communicated within that 7 millisecond time frame, and it is able to send here. So before the uh, the standard which we have maintained through my electrical testing team, it should be 50 milliseconds. Maximum 50 milliseconds of delay is permissible to eliminate any fault. But that 50 millisecond delay, that thing is obviously getting satisfied by this 7 milliseconds of there's that fast. So that that lagging but delayed signal is definitely eliminated here. So this is how fast the system is, and how robust and reliable the system is, which is required for protection of my EHV line. Yes, we do use it for differential protection also. Through a different protocol card we use it. Sometimes special load shedding schemes also we have to implement. Suppose due to any suppose my system is getting overloaded. Yes, today when we talk about load shedding मेरे area में load shedding क्यों हो रहा है? Yes, it is not something abrupt. This is also programmed. This is also engineered, and this load shedding commands are also transmitted from one substation to other substation through my through this communication system itself. I mean, everything that power system study is done. Like whenever one line is getting overloaded, and if you have to shed the load, there is a command relay which is giving a command to trip the other line. Simple. A simple mean of communication is established, and we are doing this. This is how fast the load shedding is done, how fast system recovery is also done through this terminal equipment. This is how critical this is there. And the OT network here, as I said, this is how the network which we are managing. This is our the cloud or the automation cloud which we are there. This is the multiple nodes which we are connected through this cloud. This is the Vodafone network which we are using for my different substations. This is another network which is getting connected to my server. Yes, obviously, whenever I'm doing a server, connecting multiple networks through a server, I have to maintain the my cyber security. So yes, we are having cyber security systems installed, which is the firewall, all the systems which are there here. Through all the threats, cyber threats are being neutralized based on what is there across the world. And this is the type of you can say the layer 3 router which we are using across the network through all the communication, IP based communication is there through this OSPF protocol. Yes, OSPF in detail you'll obviously learn. It's a dynamic protocol in which open shortest path first. I mean, how in simple words, if I say, if you're having multiple neighbors of a switch of this, suppose this is my switch and I'm having multiple neighbors. Even if one neighborship goes down, that neighbor is reachable through the other network. Okay, that through other paths available. So the short it will be having the primary path as the shortest path. So if that path goes down, it will take the another second shortest path. It's all that dynamic. I mean, there is no type of any static routing required for this. Functionalities layer 3, yes, these are like routers. We are using hot standby switches. Like if one switch is getting failed, the other takes over. That's how we maintain redundancy. Resiliency links, auto recovery functions we use. We use EPSR, but EPSR, as now we have eliminated EPSR. We are going purely into OSPF. We also have access control, to safeguard some any unwanted equipment being logged, connected to my network. We are able to block them to protect that threat being entering into my system. Obviously, yes. Any type of a malicious laptop, any type of a malicious USB drive, yes, these are threats to my system. And any infected workstation can kill my entire system. So that level of cybersecurity, yes, is being maintained by Tata Power. And that was all about my as a critical communication system, how we maintain here. There are lots of other systems also being maintained here. I mean, the time falls short for that. So this was the crux of what we do here in Tata Power, and that's what was all about my presentation here. Thank you.
Thank you, Mr. Kambi. That was one insightful presentation we got to witness, wherein Mr. Sukal gave an overview of communication systems and talked about fiber system at Tata Power, SDH multiplexer, layer 3 switches, and teleprotection. I'm sure this presentation was useful for all the students looking forward to making a career in the industry. Now, before we jump to Q&A part of the session, I would like to request Mr. Sukal if you could share some memorable moment as a Vesitian.
Thank you for that. Memorable moments, there are, I remember multiple memorable moments, yes. The most memorable period of, visit, how it started. First year is like school. I mean, you have got no fear, nothing to lose. You come to college, you enjoy, and you go home. I mean, it's like you're just like naive nursery kids coming to college and going home. Second year also, second year, third year. Yes, by third year, I feel, yes, you start getting serious. Yes, boss, you have to make some career out of you. You have to do something in life. Then that things start being, self-realization. Yes, we did have a lot of. We were, yes, almost one of the naughtiest batch. I mean, Nandini ma'am, we troubled you a lot. Yes. So धीरे धीरे that you can say that maturity, how the most memorable part, like we never felt that we were getting matured, and over the period of time, how that 4 years came to a point, like we are like, yes boss, tomorrow we are having a job interview. And when at that point, the day I gave my that L&T interview, I mean, it was the first core company I remember had come to visit. And I simply remember, I mean, the tension. I mean, I remember we had around 16 to 17 panels had come, and they were like, every panel had a different level of leniency taking interviews. And that memorable thing, अरे इसने क्या पूछा, उसने क्या पूछा, क्या क्या है, that people, we could see that you can see that fear and that passion in the people about what that that interview is life changing. Today you clear the interview, you are getting something, your life is changing to something. So we, joining 4 years back and coming to a position wherein within a couple of minutes or a couple of some uh, 15 minutes your life is going to change for the better. So that itself, that journey, I'll not say moment, the entire journey I feel was memorable. Whether at least for me that was memorable for me. I mean, the that today I'm speaking in front of people. I mean, whatever I am able to be here, I'll always that uh, thing itself is through my professors here. So that itself was entirely today after 5 years of passing out. I really, what do you say? I'm jealous of all the people like that pressure of profession, pressure of thing is not there. We didn't have in college, and we used to enjoy life. Yes, we do enjoy here, but yes, thing always there. So it was totally a journey, wonderful journey of my engineering. A lot of events, lot of yes, we did study for my we used to study. Yes, it was totally memorable for me. No, this was very much. And I'm not giving a specific moment, but yes, I'll say the entire journey of 4 years was memorable for me.
Thank you. That was indeed very sweet. Let's quickly move towards the Q&A section now. So the first question that we have is, could you please throw light on your roles and responsibilities as a senior engineer in L&T and as a lead engineer in Tata Power?
In L&T, as I was placed, I was got placed as a graduate engineer trainee. Obviously, as a trainee in L&T, yes, multiple you can say orientation programs, going through multiple sections. Like L&T was a big conglomerate. Obviously, today also it is a big conglomerate of multiple phases like construction. You're going into power. You're going into so many infra. So all that, yeah, what you can say, orientations happened. Then I got placed into electrical automation. I mean, to be very much precise, I got placed in L&T through Visit and in electrical automation group in L&T. So that's how I got placed. And in L&T, once I got placed in my electrical automation, directly I was assigned this project. This is the project you have to do. One of the most dangerous projects, but yes, it is required. Sometimes you do realize in your career when you are doing when in your job, you realize something. Yes, you have to face difficulties today. Why am I saying basic electrical engineering today? Because I am in a power utility company. Okay, power utility company, I have to deal with electrical systems. And if I'm a communication engineer, I cannot say I'm a communication engineer and I don't know about my business. Whenever I'm in a company, see, be in any company, you need to know what your business is all about. Okay, you can't say I know only this and I'll focus only on this. You need to have a wide background, wide, you can say overview. So yes, basic electrical engineering, you must know properly. You must know it properly. Yes, and MCQs. MCQs you have to solve. Like people who are, I suppose, in the audience, there are some people who might be preparing for GATE, some for IES. Yes, and some might be preparing for other competitive technical exams for BARC, some other PSU. Yes, people preparing for GATE, you are already preparing on basics. So for core companies, you have to be strong on your basics. Prepare on your basics, make them clear, simple, and common engineering sense. I mean, you have to think like an engineer. You have to differ yourself from an engineer, from a commerce graduate. Simple. In a company, if you're sitting, I mean, you have to be that edge. That engineer has to be an edge apart from a normal thinking person. That's how you have to be. I mean, if somebody throws upon a situation to you, your way of thinking, is evaluated as an engineer, not on how much book your sense common. It's how interesting how much interest you take into that. I mean, suppose you enter into engineering and somewhere you realize that it's not my forte. That does not mean that you will not land up into anything in your future. I'll never say that. Everybody has got equal opportunities everywhere in life. There is no end to it. You have to simply knock at the correct door and you will get it. But yes, people who wish to have a good career, who wish to actually focus into core career, core industry, yes, you need to have at least some decent score. Decent score you need to have. Uh, Although nobody will ask that today at the 5 years I've completed, nobody asks me how much I scored in my 10, 12. Nobody will ask you. But yes, decent score is required because it becomes it becomes a part of your resume, and you can never delete that. You must have some decent score. It is required, but yes, and finally, more than that, I'll always say your basics have to be very much clear, and you need to have situations like basics have to be clear. And whenever you're working in any company, more than your technical knowledge, how what is your approach towards solving that problem, that is more important. I mean, more than how much you know, how see, you may go wrong. I mean, we are humans, we may go wrong somewhere, but that should not be preventing you from not doing something. How well you approach a problem and how well you're able to tackle a problem, that is what is important. See, correctness of that thing is another achievement, but how well you approach it through your engineering sense, through your this, that is what is required. And yes, I will say, as a core engineer, you must have a decent score. It is required because many a times in placement criteria, in admissions to good colleges, you need to have a decent score, because in core companies, yes, they have a certain criteria of maintaining some, say, a 7.5 or 8 CGPA. Yes, you have to maintain. If you are going towards core companies, you need to have that thing maintained. uh, I mean, that is what required. And even when you're switching your jobs also now, they do check your academics. They do check your academics. And even today, after 5 years, I'm applying anywhere for any higher education. Yes, they do check. There is a criteria for minimum XYZ, minimum say 60%, 70% of your academics is required, because that becomes one type of a filter to filter that best among the lot. It is sometimes a filter for selection criteria. Yes, I mean, this is a very crystal clear thing I'm telling to all your aspirants here. थोड़ा सा decent score is required. You need to थोड़ा slog your self for 3 years. I mean, that's it. You have to do your best. I mean, you can't be complacent. I mean, I'm sounding a bit blunt, but yes, I'll not mince my words. You have to be a bit more serious, and you have to do it. I mean, my professors might agree with me on this.
Last but not the least, quick advisor tips for the students.
Quick advice, quick advice. Okay, quick advice. Simple. I'll again repeat. Basics, fundamentals clear. Yes, you are going to, obviously people will study. Definitely they are going to study, but basics have to be clear. And secondly, what is more than the technical skill? I feel your English communication has to be very simple. I mean, whenever we are communicating, be it in any company you join. I mean, you go into a software company, you go into a core company, you require proper communication skills. That is what is required. Proper good email communication. Yes, this is a subject I feel for every engineering you need to work on this. This is also required as a in a profession, so that you are able to communicate with all type of people in your profession. This is also required. So this is also one of the tips I will give.
I'm sure you've responded to each query with a wholesome answer. Now, I, on behalf of the Department of Electronics and Telecommunications, would like to express gratitude towards Mr. Sukalp Kamdi for giving us time from his busy schedule and catering to the doubts of the students. Now, before we end the session, I would request all the attendees to fill the feedback form shared in the chat box and earn a certificate. Once again, thank you, Mr. Sukalp Kamdi. Thank you.
Thank you. Thanks a lot.